With example number 11, we're given f of x is equal to the quotient of 2x plus 1 divided by x cubed, and we're charged with finding the second derivative's value at x equals 1. Okay, so again, before we can find the second derivative's value at x equals 1, we need to find the second derivative. And before we can find the second derivative, we need to find the first derivative. So we get to the first derivative, then we use that to get to the second derivative, and then we plug in our 1. That will allow us to get f double prime of 1. Okay, so we see 2x plus 1 divided by x cubed. So we have to recall here that this is going to require the quotient rule to get the first derivative. So let's go ahead and look at the quotient rule. All right, we remember it however is best for us. Again, my recommendation, we think of this as bottom d top minus top d bottom all over bottom squared. All right, so we write our bottom term first, which is x cubed, and we multiply that by the derivative of the numerator, d top. The derivative of 2x plus 1 would be, it would be 2. Okay, so there's our denominator times the derivative of the numerator minus, now we alternate, so now we're going to derive the denominator, 3x squared, and we're going to keep the numerator, which is 2x plus 1. Okay, there's our numerator of our derivative. Remember, it's all over bottom squared. Okay, so bottom d top minus top d bottom all over bottom squared. Okay, now we have to derive this again, and this is kind of messy at the moment, so it might make sense if we were to just simplify this a little bit. Let me get my other marker again. And we know that this is really 2x cubed. And if we distribute the 3x squared times, or rather negative 3x squared times 2x is negative 6x cubed. And negative 3x squared times 1 is minus 3x squared. Okay, so if we rewrite this a little bit, what we have here, we have 2x cubed minus 6x cubed, which means that we're going to be looking at negative 4x cubed. And minus 3x squared. In the denominator, we have x cubed being squared, which will be x to the 6th power. So there is our first derivative. Okay, now we have to derive this, and that's going to require the quotient rule a second time. So we're going to go to f double prime of x. All right, that's going to be another fraction bar. And again, bottom times derivative of the top. So x to the 6th, and we're going to multiply that by the derivative of the numerator. Negative 4x cubed is going to derive to negative 12x squared. And minus 3x squared will derive to negative 6x. Okay, we're getting a lot of use out of our power rule now, and our sum difference rule, our coefficient rule. They're all coming into play. We're using them as well as the quotient rule. So there's bottom d top minus, now we're going to keep the numerator. We're going to keep the negative 4x cubed minus 3x squared. And we're going to multiply it by the derivative of the denominator. And the derivative of 6x, or rather x to the 6th, will be 6x to the 5th. So we've got that as well. Okay, all over the bottom squared. Okay, so there is our second derivative, right? Now, we're interested in the second derivative's value at 1. So let's plug in 1 here. So f double prime of 1. When we plug in 1, we get 1 for x to the 6th. We don't have to write that, but I'll put it in. And then we're going to have negative 12 minus 6. It's a nice thing about plugging in 1. It makes everything kind of simplify rather easily. Minus, that's this minus sign right here. And then we're going to have, when we plug in 1, negative 4 minus 3. And over here, we're going to have 6. We can put parentheses around that. In the denominator, we have 1 to the 6th to the 12th. So that means we just have 1. Right? So our answer, what we're looking for here, seems to be negative 12 take away 6, which is negative 18, minus, and then we have negative 7 times 6. Negative 7 times 6 is negative 42. So we are subtracting negative 42. And again, that's all over 1, but we don't need to write that. Negative 18, double negative here, plus 42. So that's the same thing. as 42 minus 18, or 24. So that would be f double prime of 1.